Shall we get started? Am I audible?
Yes, yes, sir. You are audible.
Okay, good. Um, okay, okay, let's get started. Uh, Let me know if you can see my screen. I'm going to share it now. Hi, good evening. My name is Amit Bansal. Are you able to see my screen?
Yes, yes.
Okay,
Yeah,
good.
it's
My name is Amit. My name is Amit Bansal. I'm a research scholar at Indian Institute of Science. I'm in my fourth year, and I've been working on gallium nitride based devices. So we are going to be talking about the you all are here. You all are here because you have been to this portal. As we all know that NPTEL has been a name for now years now. I did my preparation using NPTEL videos. The new thing that NPTEL has added is the video solutions to previous gate questions. I hope you have seen this portal. You go to gate video solutions. For now you don't see physics here. We'll be adding this. I'm conducting this session. We have a live mentoring session where you can choose department wise which sessions you want to choose. So you are choosing physics, and currently we are here Sunday 7 to 8 p.m. I'll be broadly interested in three topics, and my fellow tutors will be taking care of all of the topics. In case some topics are missing, don't worry, we'll take care of it. I guess why I went to NPTEL videos, and I guess why you are here is because the NPTEL has a brand. I mean the videos that are there are of qualified teachers and experienced ones, that too, in every field. You take it physics, you take it electronics, you take it mathematics, metallurgical engineering, computer science, and everything. So that's why you are here. The good thing about that NPTEL that has done is that you can, for instance, if you go to electronics and communication engineering, you can select subjects. Let's say I want to study digital circuits, and I want to study topic of combinatorial circuits, and you can get videos like this. Physics videos will be up soon in this manner. That is the one thing that this portal is going to give us in the next few weeks, hopefully. Next thing what I wanted to share with you is, have you all gone through the physics syllabus for GATE? Just say yes or show of hands.
yes, sir.
Okay, even if you don't have, I advise you to go through. Here I am presenting a snapshot. Have you guys seen such kind of weightage breakdown of questions?
Yes, sir.
Okay, good. This is a very useful guide in how to prepare. Every year you know what is the gate cutoff for physics. Accordingly, you can choose your strengths and weaknesses and prepare accordingly. Here we are going to cover every topic in detail as much as possible. But it's good that you have that you have a guide in hand that where you are going. For instance, mine atomic and molecular physics was weak, so I didn't attempt any questions of it. I knew I didn't need to, because my mathematical physics and classical mechanics was strong enough, my electronics was strong enough that I can afford to skip atomic and molecular physics. I suggest you find your own strengths and weaknesses, discuss with your tutors, with your fellow batchmates, everywhere, anywhere you can find guidance, just try to find it. Right, now before we go forward, I need to ask you a few questions. Okay, what is the educational background, because this will help me prepare me my content as to what your requirements are. So I need to know what is your educational background. So let me start. How many of you have MSc physics degree, are in MSc physics, or have gone through MSc physics? Just type yes in the chat box, please. Whether you're preparing, whether you're in MSc physics, or you have already completed MSc physics. Okay, I see 4 years. Okay, good. How many of you are yes, I was coming to engineering. Okay, good. How many of you are bachelors in any field, engineering or science or anything? Just please write yes in the chat box. I know Yash has seen B mechanical engineering. Okay, Amulya mechanical final. Okay, So we have MSc Physics people and okay, good. My second question would be, what is the purpose of joining this platform? Is it, are you preparing for jobs, or are you prepare? You know, I know you're preparing for GATE examination, but is that GATE examination is for job purpose or for, let's say, masters or PhD? Just say job. If you want to for job, just okay. Higher education, okay. PhD, GATE, PhD, okay, okay, good. I think one person, okay, MTech or PhD, that's fine. PhD, okay, good. So the cutoff for PhD might be a little bit higher, but we are going to cover every possible concept and we are going to address every possible doubt of yours. So you are able to cover. We intend that you are able to gain your knowledge and cross any cutoff that is there. Okay. Now the most important question: what are your expectations from this portal? Okay, now I need you to speak. So I'll be unmuting you. One by, if you don't want to speak anything, it's fine. You can just say pass. It's fine. Okay, I'm going to. Yeah, you can unmute yourself. So I'll start with whatever list is there in front of me. Amulya, what is your expectation from this portal? From this?
So
Yeah.
from this, I am expecting to get a clear-cut content for the GATE exam. So
Okay.
because if I search for the NPTEL content, it is quite vast and
Okay.
not exactly to the point.
Okay.
And other coaching material is they require fee for that, and this content is free, sir.
Okay. Okay. Good. So for content. Okay. Thanks, Amulya. Aparna. Aparna, are you there?
Yes, sir. So I think it's a more stressful platform to get to know the solutions, and I expect more classes or the basic understanding of the concepts which I have to prepare.
Okay, okay, fine, good. Thank you. Gopal?
Good evening, sir.
Good evening, Gopal. Please go ahead.
Yes, sir. Yes, sir. Uh, Sir, initially, when I got the mail from the NEPTEL, like the GATE coachings are started,
Okay,
I was expecting that some IIT's professor will teach to us, but it is good to see that the research scholars are guiding us and like they have experience, and it's very good. And I also need a platform for Saturday, Sunday. Since I'm doing a 6 month project and I have to go departments and the working days, and
okay,
I was planning to prepare at Saturday, Sunday.
okay, okay.
So luckily these sessions are on Saturday, Sunday. So it was good to keep me engaged on the weekends in my preparation, and hoping that the discussions and the lectures provided here will be enough for me to get a good cutoff.
Yes.
Since in the first attempt my GATE I was not well prepared, and I was just able to clear the cutoff. So this time with the good preparation I want to clear with the good rank and get a good research institute.
Okay, we'll make sure you do that. Okay, thank you, Gopal. Ishwarya? Ishwarya? Okay.
Hello?
Yeah,
Hello?
yeah. What are your expectations from this portal?
Sir, I just expect you to teach us how to approach a problem and
Okay.
how to solve it.
Okay, good. That will be the crux, the concepts and how to approach a problem. That's what we will, me and my fellow tutors will be taking care of this. Okay, good. Thank you. Rakesh,
Hi Amit, good evening.
good evening.
Yeah, certainly my expectation is from some good lectures as well as course materials. And one of the thing that I am looking for is the test is yeah. So right now we didn't see the physics portal there. So is it come in future?
Test series?
I didn't see that test portal there in physics. Chemistry and mathematics is there, but physics is not there.
Yeah, so the content, the thing is, this is only this year that NPTEL is launching this program for physics. We had for earlier, like electronic and computer science, we had it. So we are going to do
Yeah,
two
yeah.
things. We are going to map the lectures. Let's say we have physics lectures from reputed faculties all over India on.
Yeah, that's okay. So can I get some test like
I'll,
other
I'll, I'll,
branches?
I'll ask NPTEL and we'll get back to you surely about this. So what is the timeline on the test series? That's a specific
Okay,
question, right?
okay.
We'll get back to you.
Yeah.
Don't worry. Okay.
Yeah. So my expectation is just brush up the concepts and
Yeah.
just
Okay.
to solving good way to solving the problem.
Yeah, we'll do that. Okay. Thanks, Rakesh.
Yeah.
Rishabh?
Thanks, Anil.
Rishabh, if you can hear me, please. Yeah.
Yes, sir.
Yeah. Okay. My humble request. Please don't refer to me as sir. Please call me Amit. I'm referring you by your
Oh.
name.
Okay, sir.
Okay. Go ahead, Rishabh.
Yes, sir. This is my first time. Um, so I don't know about this NPTEL.
Okay. Okay.
First time I joined.
Okay, good. So I'll after you guys finish introducing yourselves, I'll get another 2 minutes of what NPTEL is. Don't worry. We'll talk
Okay.
about it. Okay. Sandeep. Sandeep, are you here?
Yes, sir.
Yeah.
Sir, I am currently in second year of MSc, so my expectations are even if I am able to clear the cutoff,
Okay.
that will be enough for me currently.
Uh-huh.
So what I am expecting is basically just clear my concept and basically make a revision plan for me. That's all.
Okay. Okay. Good. That will help you because we'll be touching all the questions. We are targeting all the previous 10-year questions of physics, so that will surely you'll surely brush up your concepts. Okay. Good. Next we have. Okay, I forgot. Sandeep. Shraddha.
Yes, good evening.
Good evening, everyone.
My main to find the content because I always fear to attempt the question.
Okay, so we'll be telling how to approach the question that will be dealing with. Yeah, so we'll try to sort out your doubts regarding that. Okay, good. Good. Anything else?
Okay,
Okay.
no.
Okay, thank you. Shruti. Okay, Shruti has sent us a comment. My expectation from NPL is a clear concept, practice, and how to prepare to get a good cutoff for PhD. Surely we'll do all these and maybe some more. Thanks, Shruti. Next is who's next? Utkarsh.
Hello.
Yeah. Hello, Utkarsh.
Everyone. Good evening. So I just completed my MSc in this year only, May 2022.
Okay.
So my expectation from these lectures will be that it will bring little momentum in my life, in little momentum for planning or having this examination because this time I am little down, so I think this will bring little momentum to
Okay.
this preparation.
We'll try that because we'll have, as somebody mentioned, that we are doing on weekends and after office hours. And we'll be regular. So every week we'll be meeting. Me and not just me, but my 5 other fellow tutors. So we'll be trying. We'll organize these sessions and we'll keep pushing you. That's it. So we'll try to ensure that you guys have momentum. Okay. I'll summarize this after Yash. Yash, Utkarsh, please mute yourself.
Okay, thank you so much.
Yeah. Yash, yeah.
Hello, Amit. My expectations, like I have done many NPTEL courses previously,
Okay.
so I did understand many concepts by using NPTEL platform, and I
Okay.
did physics courses mostly.
Uh-huh.
So with this live sessions, I am hoping that I can solve gate questions like easily, like understand the concept of the how to solve the problems
Yeah.
more
Okay.
faster. Like I can solve the problems, but I'm much slower. Like for
Okay.
the
No.
entrance exam, it need to be much faster, right?
Yes. Yes. So
So
I'll tell you how to. I'll tell you how
yes,
to
sir.
approach my questions, and for
Yeah.
me and my fellow tutors, will
Yes,
definitely.
the questions have multiple concepts. Single questions have multiple concepts. Like that
Yes.
mostly confuses me. That's why.
Correct. Correct. We'll see. We'll
How to approach that is
correct.
my
Okay.
expectation.
Okay.
Thank you.
We'll try to help you with that. Okay. I think one more person joined after. I think Abhiram.
Yes, sir.
Yeah. So what are your expectations from this portal and from this session, Abhiram?
Just my accept. I, sorry, just collect the exam.
Okay, ठीक है.
My
That's the broad goal.
expectations.
That's the broad goal we are going. If you have any specific in mind, just let us know anytime. Just stop me in between. Okay, okay. So I have listened to your expectations and what your. I can send some things that you need. So first, the most recurrent theme was content. We will be touching upon content, but if you want in-depth knowledge, I will still strongly, we for every video we'll give you some NPTEL video links which were taught by professors. So I suggest, if you need some in-depth understanding, you do visit those links, try to clear concepts and ask doubts. So for instance, this week next week I might be doing operational amplifiers. So you will get to know that you can go to NPTEL portal and find the links for operational amplifier videos. I suggest you watch them. Even if you don't watch them, I will be doing some refresher on operational amplifiers. That will do in every question. So your content basics will be covered in depth. Of course, you will have to read. If you have any doubt, come back. So I'll be sharing my email ID at the end, and you can note it down. If you have any doubts regarding to this session or for further coming sessions, you can get back to me or my fellow tutors, whomever you feel comfortable with. So we'll cover that. The lecture and material is available on NPTEL. If there is further any reading that is required, we'll let you know. Or if you need that if you want you that you want to know that should I read this or not, ask us. See, please understand, I am sitting here. I was in your position a few years ago. I was not sitting here. I was sitting like I was joining. I did not have this facility. So I was in your position. So I understand. My fellow tutors understand what you went through and what your hopes and aspirations are. We'll take care of that. So don't worry about that. And that's why we keep not very strictly formal. Just pause, ask questions, raise hands, chat among yourselves with your tutors. Be a little frank. That's all what I need you to do. Okay. So now what I'll be doing is I'll introduce to you what my pattern would be. So first I'll introduce the questions which I'll be in every session. We'll be doing concept building, but we'll be doing concept building using some questions, not some randomly. So what I have done is that, for instance, let's say for operational amplifiers there have been 5 questions in the past 10 years. So I will solve those 5 questions in front of you, and you will ask doubts, and I'll also explain the basics of operational amplifiers. Just an example. Today we'll go through today's session, and you'll get to understand what I'm talking about. And then of course I'll take your doubts. You can pause, you can ask doubts, you can do what you need, and then I'll share with you. I'll ask you what should we do the next week, and then accordingly when we meet next week we'll do that topic. Is that okay? Any modifications or any concerns you want to raise, please speak, or you can speak later, it's fine. Is it clear till now what we have talked about?
Yes.
Yes, sir.
Okay, good. Thank you, guys. Now I'll be sharing my screen again. Okay, let me share my screen. Are you able to see the screen? Full screen?
Yes, sir.
Yes,
Okay.
yes.
Okay, so this is week 1. Today is August 14. So this was the first question that I chose. So I'll read the question for you if you're not able to see. This is a question from Physics 2022 paper. So we have a power supply. It has an internal resistance Rs with load voltage Vs, source voltage Vs, and we have connected a load to it, and the question says that there has been let me turn on my pen. So it has an internal resistance Rs and it has a drop of 5 volts. A load is connected to this power supply and the voltage dropped across load is 4 volts. We need to find out the value of RL over Rs. So you must have seen these problems. We'll come to it. I'll come to it. This is a similar question again. So again we have a voltage source and a current source and a load is connected to it, and we have the, have you heard of this term, power transfer efficiencies? Have you guys heard this term? Yes or no?
No, sir.
No, I didn't.
Okay, good. Then I'll explain in my video. Okay? I'm just introducing the questions. I'll read the questions again and we'll solve it. Don't worry. Okay?
Yeah.
So these are the questions that I have for you. If time permits, we'll solve this question also, but I don't think we'll have time. So this is the concept. Okay. On the left, you can see an ideal voltage source. Can you see that?
Yes, sir.
Okay, so ideal voltage source has a voltage source Vs and it has zero internal resistance. You can see that. This is an ideal voltage source. This is a practical voltage source. It has again Vs, but it has finite internal resistance Rs. We'll connect loads across it and we'll drive the circuits. We'll see how it happens in a while. So when you connect this, now current will flow here, another current will flow here. We'll try to find out how much power is being delivered to this load and this source resistance. We'll do that in a while. This is a voltage source. You can see that. This is how we represent a voltage source. Similarly, this is how we represent a current source. This is the nomenclature for current source we represent by arrows. You can see here and here. Voltage source we typically represent by polarity, or you must have seen this symbol. Correct? This is also a voltage source. Am I correct or not? Please say yes or no.
Yes, sir.
Okay, good.
Yes, sir.
Okay, good. So now, and these are some diodes. If we come to this, I'll talk about it. Okay. Let's see if the time permits or not. Okay.
Sir,
Yeah, go ahead.
sir, for the example of a voltage source, we can use a battery, right? So, what is an example of a current source?
What is an example of a current source? Okay, good question. Have you heard about FETs or BJTs, bipolar junction transistors or field effect? So we make a circuit using them as a current source. We can do them. When we come to FET questions, okay, then we'll answer your question. There is something called a mirroring circuit. We use them to create current sources. This was a very good question. Battery you see in your hand, in your mobile phone you have lithium ion battery, in your remote control you have those AA and AAA batteries, but you don't see a current source. So yeah, it's there. We'll see that. Good, we'll see that.
Okay.
Yeah. Okay. So now what I'll do, I will play some videos for you. Just hold on a second. Hello and welcome to video solutions of GATE. Are you able to hear my voice?
Yes, sir.
No, in the video.
Yes, Amit.
Video no.
Okay,
The
good.
video no.
2022 physics paper hosted by NPTEL. The
No,
problem
sir. In video no.
reads as follows. So you're not able to hear the audio, but what is on your screen right now? Currently, what are you seeing?
It is video. Video is video. Your video.
No. What
The
is
video
it?
is playing, but no audio is coming.
Personality.
Okay, no audio is coming.
Yes, sir.
Okay. ठीक है, then I'll speak.
So the video is fast.
Yeah, right
The
now
video is fast.
a power supply has internal resistance Rs and open load voltage. Now are you able to hear anything? Equal to 5 volts.
No, sir.
When a load resistance R then I'll is connected to the power supply, a voltage drop of VL equal to 4 volt. Okay, so this is a power supply. Now you're able to hear my voice?
Yes, sir.
Okay, So this is a power supply. It has an internal resistance RS and an open load voltage VS of 5 volts. We have connected a load resistance RL. So I'll simply show you the circuit what it looks like. This is what it's saying. So we have a voltage source here VS, and this is what the real voltage source looks like. An ideal voltage source plus an internal resistance. Here we have a load resistance RL. So this box, this battery is being used to drive this load resistance, and we have been given that VS is 5 volts, which is here, and the voltage measured across the load is 4, using a voltmeter, is 4 volts. We are required to find the ratio of RL over RS. Okay, so we'll do that. So here what you can see is, I'll move a bit forward. Okay, so here you can see what I am doing is that so this is my ideal voltage source I talked about. So this has 0 internal resistance, and when I connect a load connect a load RL, a current I will start to flow. Just excuse me for a second. Kirchhoff's current law. Do you hear an audio now? Node. Here we can see in case there's a problem with audio. Anyways, okay, I'll explain.
The screen is also gone, sir.
Screen is gone? That shouldn't be the case. Okay, I'll try. Is it visible now?
Yes, sir.
Okay, good. So what we have here is
Yes, sir.
so this is the ideal voltage source. So when we apply a load RL, a current I will start to flow. This is very simple circuit. Similarly, in a practical voltage source, if we apply another load resistance RL, let's assume current I is starting to flow here also. So you can see that. So if I write KVL here, can I write KVL here? What will the KVL? Can you tell me? If I write KVL in this loop, can somebody tell me, please? If I write KVL,
VS minus IRS.
IRL.
IRL. Yeah. So, okay, sir. IRL equal to 0.
Equal to 0. So we'll get VS equal to IRL. Correct?
Yes, sir. Yes.
That's what I'll get. VS equal to IRL. So what I'll get here is,
Sir?
Yeah?
Sir, I cannot see the screen though.
Is it the problem?
I rejoined. I
to pin.
left the meeting and rejoined, but screen is still not available. For me,
Try
English.
to pin this kind of thing.
Try pinning that might help. Okay.
It's already pinned.
Okay, I'll do it again. Don't worry, I'll do it again. Your name is?
Yes, sir.
Okay. It should be visible now, I hope.
For both, it's only your initials are showing up. A screen is not showing up.
Is it for everyone?
some-
No, it's visible to me, sir.
No, sir. No, sir.
Okay, this is very strange.
Yes, sir. I left the meeting and rejoined too. Then it's not showing up.
Who can see? Who can see my screen? What's your name, please?
Sir, me, sir, Gopal.
Yes, sir. I can see.
Okay, then I think then the Gopal is correct. I think you need to just figure out an option where you can see my screen.
Let me retry. Let me leave again and join again.
Yeah, do that.
Okay.
Do that. Okay, where were we? So
Yes, yes, sir. Now it's visible.
okay, good.
Problem.
So let's say I applied a load RL here, and similarly I applied a load RL here. Okay, so if I write KVL here, as someone told me, it will be Vs minus IRL equal to 0. Correct?
Yes, sir.
And V out, what will the value of V out? V out will be simply IRL. Correct? What's the output voltage here? It will be IRL, and then this will be Vs. Correct?
Yeah.
Yeah. Okay, so what we can see that, so what is the voltage being delivered to the load? Vs. What was the source voltage? Vs. So what we say is that all the voltage of the source is being delivered to the load. In technical terms we say this. So whatever, let's say whatever juice this guy has, all of it is being given to load, which is not happening here. We'll see. Can someone tell me the expression of KVL in this loop? For this circuit, let's say current I is flowing. Can somebody tell me the expression?
Vs minus
Vs
IRS
minus
Yeah, Vs minus
IRS
IRS, okay,
minus IRL.
minus IRL equal to 0. Okay.
Yeah.
And again, what will be the V out?
V out will be the IRL.
V out will be IRL. Very good. Okay, so let's try to find out the value of V IRL. I just need to find the value of I. So from here I can get I equal to, simply solving this, I'll get Vs plus upon Rs plus RL. Correct? I'll put this value here. So this will be Vs times RL over Rs plus RL. Now you see, this battery can supply Vs voltage. Let's say Vs is 5 volts. Okay? And let's say real life example, let's say RL is 5 volts. RL is 5 kilo ohms. RL, and let's say RS is, let's say RL is 4 kilo ohms and RS is 1 kilo ohms. So what will happen is that V out will come out to be 5 times 4 upon 1 plus 4. So this will come out to be 4 volts. What we are seeing, although the battery is capable of providing 5 volts of voltage, the load is only seeing 4 volts. Where is the rest 1 volt? This fellow is eating up the rest 1 volts. Technical terms we say that the voltage has dropped inside the voltage. So this is the voltage source in the dotted line. So what we say is that the voltage, not all 5 volts is being delivered to the load. 1 volts of voltage is being lost inside the voltage source itself. Similarly, we can do for current sources. So I'll make RL here. So again, what will be the current delivered to this? Can somebody tell me? What will be the current that will be flowing through this branch? Quick.
Yes.
Sorry?
IS.
IS. Why? Because here there will be no current. I equal to 0.
Yes.
So if you apply KCL here, so we'll say IS equal to I plus 0. So I will be equal to IS. So what do we see? This current source is capable of providing IS, and what is being delivered to the load? IS. So we will say this is an ideal current source. Again, RL. Will I be equal to IS in this case? In this case, practical current source case. No.
No, sir. It was, yes.
IS,
No.
and let's say this to be IF. So we'll say IS equal to IL plus IF. So IL will be equal to IS minus IF. What does this mean? IL will always be less than IS. Let's say IS is 1 milliamps. So IL will always be less than 1 milliamps. This means some of the current, rather than going to the load, is being taken away by the by this guy itself, by the current source itself. Now we'll come back to our problem. So what was our problem? We'll again see the problem once. Where was it? Here it was. So power supply has internal resistance RS and open load voltage Vs equal to 5 volts. A load resistance RL is connected and a voltage drop VL of 4 volts. We need to find RL over RS. Let's try to solve this problem, and stop me anywhere if you have any doubts. Okay. So again, I'll assume a current I is flowing through this circuit. Okay. And I'll simply write the expression. What will I write? I'll applying KVL in this loop. So I'll write Vs minus IRs minus IRL equal to 0. Okay, I'll get I equal to Vs over Rs plus RL. Now VL has been given 4 volts. I can calculate VL equal to I times RL. How do I write this? Ohm's law. I am applying Ohm's law across this resistor. Excuse me for a minute. Okay. Right. So what is the value of I? The value of I is Vs over Rs plus RL multiplied by RL. So VL is given 4 volts. So I can write 4 equal to Vs is 5 volts, 5 Rs plus RL times RL. So I'll take resistance terms on this side. So I can write Rs plus RL over RL equal to 5 by 4. So I'll get Rs over RL plus 1 equal to 5 by 4. This will give me Rs over RL equal to 1 by 4. We were required to find RL over Rs, so we'll simply invert this result and this will be 4. Okay, a few things. What I do not calculate till very last. This is a very good habit, because the more calculation I do, there are more chances of making error. So you see, I did the calculation at the very last, 5 by 4 minus 1. It's a good practice. You might want to try it. Okay, we have solved this problem. If you have any doubts, please speak, or any clarifications, anything, please speak. If you also did not understand anything, please speak.
Sir, please explain KVL and KCL rule.
Okay, so KVL is Kirchhoff's voltage law. What it says is that inside any let's say inside any closed loop, you can start from anywhere. So I'm starting from this point. So what it says is that if you encounter the negative edge of a voltage source, you write it as Vs. So since I'm moving this way, I'll write it Vs. If you encounter a resistor, like this is a resistor and current I is flowing here, so what I do is that I'll write it as the voltage dropping, this is IRS, and with a negative sign. Again, when I come, there was nothing here, so I come here, I again see a resistor RL with current I flowing, so I'll write IRL with a negative sign equal to 0. This is what is KVL. KCL would be, so let's say, so there is a current I1 coming here, I2, I3, I4. So KCL says incoming current equal to outgoing current in every node. So what is the incoming current here? Incoming current is I1 plus I3. This will be equal to outgoing current. Outgoing current is I2 because arrow is pointing outwards. I2 plus I4. This is KCL and this is KVL. These are fundamental building blocks of your solving any circuit, any electronic circuit. All right. Any other questions?
No, sir.
Okay. What I'll do is that I'll go to the next question. Okay. So there's a second question. This I have taken from Physics 2019 paper. What does it say? It says it's a very similar question to what we just solved. It says a load resistance is 4.7 ohms and power transfer efficiencies of a DC voltage source and DC current source. So what it says is that we have a DC voltage source, let's say Vs, with internal resistance R1. This is being used on a load resistance RL. This is my voltage source. Similarly, there is another circuit like this, R2 IS, and this is being used to drive on same load RL. RL is 4.7 ohms. this. So what it says is that there is a term called eta is called P load upon P total. What is P load? P load is the power supplied to the load. So what is the power supplied to the load? We'll see that. And P total is power supplied by the battery. I repeat, P load is the power supplied to the load and P total is the power supplied by the battery. There will be a difference between the two because some power will be lost in this resistor also due to Joule's law, I square R. So we need to find the product of R1 and R2. It will be very simple. We'll see that. Okay, here we are. So this is an ideal voltage source. This is a practical voltage source. Again, in ideal voltage source, I am assuming that I am driving a load resistance RL. Okay. Since it's an ideal voltage source, RS will be 0 and I'll simply write the KVL. So what will the KVL? I'm moving like this. So it will be Vs minus I1 RL equal to 0. I'll get expression Vs equal to I1 times RL. Right. Now eta is P load upon P total. What is P load? P load is power supplied to this load. What will it be? It will be, according to Joule's law, it will be current through this resistor, which is I1 square times the value of this resistor, which is RL. So power supplied to load will be I1 square times RL. Second, P supplied by the battery, it will be the voltage seen by the battery, which is Vs times the current flowing through the battery. The current flowing through the battery is I1. So power supplied will be Vs times I1. I put both of these expressions here. So what I'll get, I1 and I1 will get cancelled. I'll get I1 RL upon Vs. Interesting. Vs is equal to I1 RL. So I'll get eta equal to 1. This means, in this case, power transfer efficiency is equal to 1. This is the best you can get. What is happening? Everything which is being supplied is being given to the load. We saw it in the previous question also. Same thing is happening. There I explained using terms of voltage. Here I am explaining in terms of power. Power is a truer concept than voltage. Now, when we see a practical voltage source, I'll do the same thing. Let's assume a current I is flowing through this circuit. This is the practical voltage source, so it has a non-zero internal resistance Rs, which is being used to drive a load RL. What I'll do, I'll again write KVL. Vs minus IRS minus IRL equal to 0. What will I get? I'll get I equal to Vs upon Rs upon RL. Again, I'll simply write the expression eta equal to P load, which is the power given to the load, divided by P supplied. That is the power supplied by the battery. So what will the power in the load? It will be the current, according to Joule's law, it will be current flowing through the load resistor, which is I square times RL. I square RL divided by voltage supplied by the battery, which is the voltage rating of the battery, which is Vs multiplied by current flowing. So I'll write Vs into I and I get cancelled. I get IRL upon Vs. I know the value of I from this expression. I'll put it here. I'll do some algebra and I'll get eta equal to RL upon Rs plus RL. Okay. Now can someone tell me, is this value greater than 1, less than 1, equal to 1? Can someone tell me?
Less than 1.
Why?
Less than 1.
Why can't it be greater than 1?
Because denominator is Rs plus RL. So denominator is greater than RL. That's why.
You are assuming Rs and RL both are positive, right?
Yeah.
That is the assumption, which is true. In most real circuits, we'll see RL and Rs both are positive values, and hence this will be always less than 1. You're correct.
So resistance is negative.
There are some cases. Yes, we have some weird devices or some materials in.
Oh yeah. So okay. Some special cases.
Yes, but for the purposes of this exam and at this level, it's always.
So it's
positive.
Always positive.
Yes.
Yeah.
Okay. So it's always less than 1.
And sir, I can relate it with efficiency, like.
Sorry, I didn't understand.
I can relate it with efficiency.
Yes, that's what. Very good. I was coming.
Yeah,
to that
this
point.
is efficiency.
Yes. So what's happening is that although we were expecting, see, this is the ideal case. We are expecting efficiency of 1, which is the best you can get. Correct. Here efficiency less than 1. This is what we typically get in real life circuits. Efficiency will be less than 1. Never in thermodynamics you must have studied there. The entropy law. This energy will always go on decreasing. I mean, it will be lost somewhere or the other. That's what's happening here also. Energy is being lost, which is being seen here. This is called power transfer efficiency. Why? We are in the numerator we have power supplied to the load, in denominator we have power supplied by the battery. So that's what's happening here. Now we just saw what's happening in voltage sources. We can apply same concept in current sources. What's happening here? This is the same circuit we saw earlier in the previous question. So I'm assuming, so I'll apply Ohm's law across this. So I'll get V out equal to Is times RL. I'll again write the efficiency expression. Eta equal to power supplied to the load divided by power provided by the source. What is the power supplied to the load? According to Joule's law, current flowing through the load, which is I square, times RL, which is RL, divided by V out, the voltage seen by the current source. What is the voltage the current is seeing? It is seeing V out. You can see that here. This voltage is V out from here to here, multiplied by the current supplied, which is Is. Since Is equal to I, these will get cancelled out and we get IRL upon V out. Now V out is nothing but IRL, which we again get efficiency of 1, which makes sense because all the current which is being supplied by the current source is being given to the load. It's not going anywhere else. However, when we come here, this is not the case. Some current, Is is the total current supplied. Some current is going to the internal resistance I1 here, and rest of the current is going I here. I'll again use the same expression. Eta equal to power supplied to the load divided by power provided by the source. Power supplied to the load will be, according to Joule's law, I square times RL, and power provided by source would be V out. This is the voltage that source is seeing, times Is. V out times Is. Again, I'll simply rearrange. V out I can write I times RL. I'm writing this here, and the expression comes out to be I over Is. What is the value of so now I need to calculate I and Is simply. So I'm placing I here as, sorry, Is has Is plus I. So I can write this as I upon Is is I1 plus I, and the value of I is, if we apply Ohm's law across this resistor, it will be V out upon RL, and if we applied Ohm's law across this resistor, it would be V out upon RF. I am simply placing them here, doing some algebra, and I am getting efficiency as RF upon RF plus RL. Again, same question, greater than 1, less than 1, equal to 1 or 0. Please respond.
Less than 1, sir.
Less than 1. So again, these are, again we see that all the, why is it less than 1? It's simple, because all the current is not going to the load resistor. Some of the current is being used, some of the current which is flowing through this resistor, and that power, that joule heat is lost. That's what's happening here. Now we'll come to our problem. This was a problem. We were given a voltage source Vs with an internal resistance R1, which was being used to drive a load resistance RL. Similarly, this has efficiency of eta 1, and we just saw the expression for voltage sources. The expression is RL upon RS plus RL. So I have reproduced this expression which we derived just now here. Similarly, for current source, an internal resistance is R2 and efficiency is eta 2. The expression is R2 over R2 plus RL, which we derived over here. So the value of RF here is just R2, that's it. So RF is being replaced by R2. We were given eta 1 equal to eta 2. So I simply put this here and this here. I did R1 plus, I inverted them now. I just flipped this, both of these terms. So it will be R1 plus RL over RL, R2 plus RL over RL. I split the denominator, so it will be R1 over RL plus 1. This will be 1 plus RL over R2. 1 and 1 gets cancelled. It will be RL square equal to R1 times R2. We were required to find the product of R1 and R2. RL value is given 4.7. So when you square the 4.7, it comes out to be 22.09. It was a numerical answer type question. We had to round it off to one decimal figure. So the correct answer was 22.1. Now, any doubts, any questions, any clarifications? You want me to repeat any term? Please speak.
Sir.
all good? There's a comment.
Yes, sir.
Okay. Any
Yes,
doubts
sir.
that you have? Even if you have some doubts remaining, please come back in the next session. Okay, I'm typing my email ID here. Okay, please contact me if you have any doubts.
Sir, I was disconnected for a while, sir. Can you explain the KCL part again, please?
Okay, I'll do that.
Thank you, sir.
Let me present. KCL is very simple. You have a node somewhere. Kirchhoff's current law says that for every node, incoming current should be equal to outgoing current. So what is the incoming current that you are seeing in this node? Incoming current that I am seeing is I1, arrow is pointing inwards, plus I2, incoming, plus I3 is also coming in, equal to outgoing current is I4. This is Kirchhoff's current law. I'll write it in incoming I equal to outgoing I. So incoming I is I1 plus I2 plus I3. The arrow is pointing inwards, equal to I4. Very simple. Is it clear?
Yes, sir.
Yeah. Okay. I have given my email IDs to you guys. You are able to see that, right?
Yes, sir.
In the chat
Yes, sir.
box. So in case you have any doubt, please write an email. I'll respond as quickly as possible, hopefully within a day. I'll try to do that. Okay. Okay. If things are clear, so what we discussed essentially today was that the voltage sources and current sources are not ideal. The practical voltage and current sources have some internal resistances, and hence their power efficiencies, power transfer efficiencies, are always less than 1. This is what we learned today. We'll try to build up on this in the next session, but before we go, I need to ask you guys, what topic do you want me to cover? I am covering electronics topics for now. I'll switch once electronics topics get over. I'll switch to some other topics. But now I need to ask you, which topic do you want me to cover? I have 4 topics that I can tell you. First is semiconductors, the basics of semiconductors and holes and electrons. That's the first topic. So I'm writing it down so you can see. Topic 1 is semiconductors. Topic 2 is PN diodes, BJTs, that's bipolar junction transistors, and FETs, that's field effect transistors. This is the second topic. Third would be digital electronics. By digital electronics I mean flip-flop, your adders, and your ADC, DAC, those kind of questions. Fourth topic is operational amplifiers. So I have chosen these topics because the questions in the past 10 years, there are quite a few questions of these topics. So which one do you want me to cover for next session, or next Sunday?
Semiconductor, sir.
Okay, one more for semiconductors. For the semiconductors, please write yes. For those who want to cover semiconductors, just write yes. Okay, one digital electronics. Okay, semiconductors has 3. Okay, how many for 4 for semiconductors? Okay, one is saying op-amp. ठीक है, digital electronics. Okay, so what I'll do is that we'll try to publish a calendar, because in some other sessions this was a demand that tutors just display their calendar, but they're going to teach over the month. So what I'll try to do is I'll try to publish a calendar. You prepare your if you have any doubts, watch some videos on NPTEL or from any other source if you have any doubts. Okay, important topics for net. No, Rakesh, I'll cover all the four. I'm asking which one to go first. That was my concern. We'll cover all the fours. It's not a thing. Okay, so as far as net exam is concerned, I'll suggest the same thing. So in the starting, I shared. Okay, I'll share it again. Are you able to see my screen? Yes, no?
Yes, sir.
Yeah. So this was a screen that I shared earlier. That what has been for the last 10 years, how gate physics in what topics have been asked. So what I strongly suggest for net exam, for just exam, or for any other competitive exam, just make this table yourself, or this is available for some website. Like this is a Career Endeavor website which I'm showing you here. Thanks to them. So just see which questions are there in higher numbers, which are your strengths. I'll tell you what I did. When I was preparing, I prepared only for mathematical physics, classical mechanics, electromagnetic theory, and quantum mechanics, and electronics and solid state. I did not touch thermo, atomic and molecular physics, and nuclear physics. Nothing at all. I did not even prepare these topics. I got selected very easily because I knew these were not my strength. My background is electrical engineering, BTech in electrical engineering. This was my weak topic, thermodynamics. Atomic molecular physics, I had not even studied a word of it. Nuclear particle physics, I had not studied a word of it. I simply skipped them. On the other topics, I knew that out of total 100, the other topics were around 70 marks, and the cutoff usually was around 40. Maximum was 37, I think, for physics. So I knew I can easily clear them. Again, identify your strengths, identify your weaknesses. You need not, you should, it's advisable that you have knowledge of every topic. For competitive exam though, you must identify your strengths and your weaknesses. For net also, for net, I had this table. I'll try to find this table for net which I had made 4 years earlier. I'll try to share it within in the next cycle, in the next session. But you must try to find your strengths and weaknesses and prepare accordingly. That's my suggestion for every competitive exam. And the level of net and gate, the net and there is some differences, and some questions, please remember, some questions repeat. They do repeat, they just change the value. Like resistance value is 10 kilo ohms, they change it to 1 kilo ohms, and the question is exactly the same. So please attempt your previous 10-year questions. Gate, net, jest, jam, whatever exam you have, last 10 years is absolute necessary. Some questions directly repeat, just a change of number. 10 kilo ohms will become 1 kilo ohms, and stuff like this. Please do that. Okay.
Sir, electronics is my weakness part.
Sorry.
Electronics is my weakness part.
No, I'll cover them. It's not that I will not cover them. I'll try to cover each and every topic. That's so. What I was asking was that what should I do first? That was my concern there. It was not like I will not be covering it. We'll be covering everything. So just don't worry about it.
Semiconductor is right, sir. Semiconductor.
Sorry.
Semiconductor.
Yeah. So what I'll do is that I'll share.
Lots of people agree with. Lots of people agree with semiconductor.
Yes. So what I'll do is I'll try to find out the questions for semiconductors, and most likely we'll do in next session. If I don't find enough questions for semiconductors, then of course we'll have to do some other questions. But I think we should have sufficient questions from semiconductors. Okay. Any other thing you want to ask me? Just so now the session time is over, but I can stay. Just anything you want to ask related to this, or for like someone asked about the net exam. Who was it? I think Shruti asked, when is the net exam though? What is the date?
Next 2 months. 16 to 20 September.
September. Okay, so yeah, we'll be covering quite a bit of topics there then. Okay, one more thing. If you have some doubts of your own, okay, try emailing to the tutors. Like I shared my email address with you. Just try telling them this is my doubt. For instance, today we talked about KVL, KCL, and practical voltage source, practical current source, power transfer efficiency. If you have some doubts in them, just email your questions to the tutors. They'll try and help you. That's all. if you have, like, you are practicing something, some net question you saw, some jest question you saw. Okay, for those who are not aware, jest is again an entrance test for physics and computer science people. That's only for, I think it's joint entrance screening test, if I'm not wrong, and that's only for physics and computer science, if I'm not wrong. Net, you know, national eligibility test. Yeah, these are the exams. Okay, just ask me if you want to ask anything else related to topic or some other exams, anything.
Sir, what about the interview process? How was the interview?
Okay, so first, you know, you clear these competitive exams, and then a merit list is created. Then you apply to individual institutions. Let's say you apply to IIT Delhi, Indian Institute of Science, Bengaluru, IISER Pune. Let's say you, and then they'll call you for interviews. Then you go there, and sometimes they take a written test there also. So please be prepared. For instance, I know IIT Kanpur takes a written test. I failed in that. Okay. So it's like, it's not like every tutor you see here it's a godsend. No, we have our strengths, we have our weaknesses. It's just that sometimes in some preparation we did, and I am here, for instance. So there'll be some there'll be some written exams. IIT Kanpur definitely has. I don't know, I think IISER, Mohali or Bhopal also has. I'm forgetting which one, but they also do. After you clear written examination there, then you go for interviews. In interviews, usually it's there are 4 to 5, that depends on institute to institute. So in one institute there were 2 rounds. So first round, two faculties were there, so I cleared that. Second round, again 2 faculties were there, so they again ask questions. They ask you which topic is your strength, which ones do you want to ask. So I simply told electronics is my strength, solid state physics is my strength, classical mechanics, electromagnetic theory is my strength. So they ask from those topics only. You can simply tell them, and if you don't know an answer to a question, just simply say no. And I'll tell you, I solved a question wrong and I still got selected. Why? Because my approach was correct. I solved a question wrong, but I still got selected because my approach was correct. And that's what matters the most. It's not whether you are arriving at the correct answer or not. It's not that important. It's like, what are you able to think what is required? Are you able to critically think? Are you able to understand that there are different parts to this problem? Are you able to think that? Are you able to say that out loud? Those are the things that they see in interviews. At least in IITs, ISC, IISER, they put very much emphasis on this. That are you able to think properly or critically or not? So yeah. And if you have concepts clear, if you are solving problems of GATE, NET, JEST, JAM, it comes. It naturally comes. If you have cleared the cutoff, it's very unlikely that you are not able to think critically. It's not like that you have mugged up your syllabus and you are just writing it down. It's not a university level exam. It's not a subjective exam. You have to critically think. Your time management is also a key in competitive exams. So those are the skills that they test in the interview, and you need not worry too much about the interview. So first couple of times you might get a bit worried, but there are so many institutions. Just figure out. Now I think they are also taking video interviews. I don't know whether after COVID they have stopped it or not, but many people I know benefited from this online interviews because they could not afford to travel to far away places. Let's say someone resides in Jharkhand, and you are asking them to travel to IIT Thiruvananthapuram on Monday and then on next day to IIT Mumbai. It's not possible. Flights are costly, 9,000, and not everyone can afford it. So if there are online interviews, do appear in them. Even if you don't get selected, that experience matters a lot. It's very critical that you attend the interviews. Fill the forms if you can, and try to attend the interviews. Especially online interview, you should not skip at all, at any cost. I know my one interview was on the same day. I think IIT Mumbai and I think ISC Bangalore or IISER Mohali, they were on the same day. So I had to skip IIT Mumbai. I wanted to go there, but there was no chance that I could be in the same 2 different cities in the same working day. It was not possible at all. So yeah, that's that. It's fine. You will do fine. Don't worry about it. Just focus on the preparation for now. Once you write the exam, then you start then you start thinking about the interviews. Talk to some, if you are taking coaching, talk to them, or even better, talk to people who have qualified, and also talk to people who have failed. So I am a person, for instance, who has qualified some interviews and who has failed in some interviews. So that's better for me, I guess. Yeah. Any other
Thank you.
concerns, queries, doubts, anything? It's
Yes,
just
sir, will you
huh?
cover solid state physics too in this live
So
session?
so the thing is, I'm see, electronics is usually it's a scoring subject. That's why I chose electronics first. It's a scoring subject.
Not after the electronics
Yes,
part is completed.
Sorry, yes.
After the electronics part is completed, can you do solid state
Yeah, I'll
physics
do
as well?
solid state. Yeah, I will. I will.
Okay, sir. Thank you.
Yeah, I will. I'll do that. And some, for instance, when we'll talk about semiconductors, some solid state physics will get covered there also. So that's also the thing. So it's not like it's independent entirely. So some topics will get covered, and whatever gets remaining, we'll cover. We'll cover. There's no doubt that the whole
Like
idea
the
is,
solid state physics, most like concepts are very difficult.
yes, concepts are difficult, but that's what I'm saying. We are not doing the concepts like we will open a textbook, or I'll open a PPT and we'll start. No, I'll show you the questions, then I'll explain what are the concepts behind it, then I'll solve the problem. So the benefit of doing this way is that there are two benefits. First, your previous year questions get covered. First benefit. Second benefit, since now you have linked a question and a concept, the probability of forgetting both of them is very low. You can forget a concept if you don't know a question. You can forget a question if you don't know the concept. Here we are doing both of them together. That's the idea. That's the whole plan of NPTEL here. That we link both the things, concepts as well as problems, with a live person sitting across your screen. That is me in this case, and my fellow tutors. One request to you guys is that just try to tell your friends, your colleagues, that try to attend these sessions. Not just for physics, but if we have like electrical, mechanical, we have running course, chemistry, mathematics. We have now I think 7 or 8 live mentoring sessions running. So just ask them to attend. Just give it a chance. If they don't like, obviously no one is forcing you either or them. Just give it a chance. Maybe you get to learn something, and more importantly, we get to learn from you, because when you ask questions, I it's like I have to think about it. That okay, what is the okay, if I have to explain power transfer efficiency, what concepts do I use? Someone asked about Kirchhoff's current law. This is the question that I've heard like after 10 or 12 years. It's like that I had almost forgotten, but I revised it. It's good for me also. So if possible, you guys try to attend all the sessions as much as you can. We'll be there. The tutors will be there every for me. I'll be there every Sunday. Other people have, you know, that schedule, right? That's been shared with you, correct?
Yeah.
Yes, sir.
Yeah, okay. Just so we'll be very regular. You guys try. Tell your friends, not just from physics, from electrical, mechanical, computer science, metallurgical, chemistry, mathematics. Let's try that. Anything else want to talk about?
No, sir. Thank you.
Okay. You have my email IDs. If you have any doubts, just drop an email. I'll try to respond as soon as possible. Okay. Thank you. Have a good night.
Thank you. Thank you.
Thank you, sir.
Bye.
Thank you, sir.